looking at the applications of power electronics. This diagram here is showing an often seen trade-off between the power output of a power application and its operating frequency. The higher the frequency, typically, the lower its power capability, and the other way around. And then there is a fine line of when different experts call it power electronics and then when people call it power systems. In the upper part of that picture, and how we're going to treat it in this course here, it's mainly around here. About 100 kilowatts would be the maximum of what we call power electronics, and everything all above is typically considered as power systems here. Now, power electronics can be still various kind of things. Very often the final application is driven by the AC mains, by the grid, like air conditions or refrigerators, TVs, things like that. Or they might also be powered by a car battery, by a solar cell, or by anything else. Down in the lower right corner here, we have the implementations with discrete MOSFETs here. That's probably the stuff what we're going to focus most on. And then on the upper hand, we're going to transistors and triacs. We're not going to look that much into that. Now, operating frequency and power capability are just two of the various parameters you could define about any power application. And now it's up to you actually to find more of those parameters. How would you, as a user of power applications and as a coming engineer inside the field, define a power converter? And you can think about anything, something that's driving a loudspeaker, supplying a laptop, or that's supplying a TV.